December 7th, 2025. Guys, Pearl Harbor Day, the day that will go down and stay in infamy, won't it? A lot occurred because of that, and several different stories that led to what happened about it. And of course, we know how it all ended. But war is never good, and it was an attack on Hawaii, which was is part of the homeland. But maybe we'll have a calm December 7th this year. What you're looking at is current images of the sun. Soho is down, guys. They had some kind of problem, hardware error, they're saying. I'm not sure exactly what it was. But what you're looking at is a Soho still image. You cannot get into the movie section right now. But what we had watched for the last week or so is Sunspot 4299, and then this group right here as they were coming around this side of the sun. Now, again, these are more Earth-facing, but they've been asleep the entire time. They still are. But we've had another flare from 4299 at the top, and that's where we got the flare from maybe a week ago as it was coming around the sun. We talked about it in a video. But these are magnetically capable of X flares. And it's like, you could refer to, in the movie about Pearl Harbor, they said Japan said that they had awakened a sleeping giant. And right now we need these two sleeping giants to stay asleep until they get to the backside or whatever they're going to do, because they are directly Earth-facing. Remember, the Earth is slightly below the equator of the sun in the ecliptics, but this is Earth-facing also. It has released a CME with it. It was almost an X-flare. Let's take a look at that. And it's hard to get much closer than that. This line right there represents the beginning of the X-flares. This was a strong M8, I think it was. But again, very powerful. And it did send out a Earth-directed coronal mass ejection. So that's going to affect everybody that is susceptible to that. Probably get a G3 magnetic storm. Had blackouts, radio blackouts over much of the Pacific. So it was a powerful blast. Now, this is the model of the CME, and I've got it paused right before the impact point. You notice here, this is Earth, and this is plasma density, how thick that proton cloud is. And then this is the Earth here, and this is radial velocity or solar wind speed. And so your impact points, again, at 0400 Z universal time on the night will be tomorrow night around 11 p.m. to 12 p.m. will be the initial peak that we'll see in both the plasma density and the solar wind. And that would be on the East Coast Central time. Right in that period of time, tomorrow night, just before midnight, we should start seeing it. Let's play this through. And it's going to last almost a day. These are days here. So your impact here, and then it finally declines into the next day. So we got around 24 hours of dealing with it, and possibly a G3 magnetic storm. You can see it leave the sun, and the Earth is in the green dot right there. Now, let's take a look at this event on LASCO C3. The sun is behind this occulter or blocking disk. This is Mercury, guys, coming in. We did a video yesterday showing what it looked like with a sodium filter, and you could see that it has a debris trail. I mentioned that for years they had called it Comet Mercury, and because of the way it acts, and I think it was closer to the Earth at that point. So, again, you may have what's called a declining radii. And this thing, as gravity slowly pulls it closer and closer to the sun. We'll see, but it's a beautiful planet. But now if we go into the 6th right here, watch. That's the 5th, the 6th, late night in the 6th, last night. We had this CME come from the center part of the sun right there. Look at that. It's called a full halo, and that means it radiated out in all direction because it's dead center almost. That's why we're starting to feel it. We already had the impacts of what you saw in the 4th and 5th as far as side swipes and things, but this one happens to be directly Earth-facing. So we're going to have to keep an eye on it. Again, beautiful images. Now let's go live to CERN, guys. Clock's top right there. That's European time. They're on the Franco-Swiss border, basically. And right now they're running peak power. This line is the culmination of the blue and red lines collision. They're creating power and energy there. And in this case, and you'll probably see this move, the power just went over the two lines. So this is approaching 7,000 gigaelectron volts, or which would be 7 teraelectron volts per beam. And so the black line rising indicates that they're really doing a jam up job right here, guys, powering everything. Now, the reason I'm coming here is because I think they take advantage of the situation when we have solar flares and things like that, because the Earth shields are hit. They are tied into our Earth shields. We'll talk about that. And I think it helps power up. Maybe they absorb some of the power. But what I do know is when it happens and they power up like they're doing right now, our shields are being pulled closer to the Earth, almost collapsing in some cases. But again, we're almost, it looks like they're at full power. You notice that they're above the beams here. That's about as hot as I've seen it. We're looking at it live. And guys, looking at beam 1 and beam 2, they are almost identical as far as windage and elevation. I don't think that's what they call it, but that's what I call it. Windage would be here, elevation on your scope here. And then they're shooting through a long tunnel. It's about 17 miles long. And when they hit, they collide, they create that energy, which they usually by this time of year, they are shut down. But when they get that collision, they create things like the photon energy, the what they call luminosity peaks, things like that. But one thing for sure is what it does to the Earth's shields. Again, we're looking at it live, and they are pretty much dead on it right now. Looking inside that. And again, you're looking live, but you can see from 7 till 9, so they had 2 hours of peak luminosity here. This is Atlas. That's the big machine. CMS is the one down from there. Then you've got LLCB. Let me pull this down. And Alice. 4 machines involved. Now, you can tell that Atlas was involved for nearly 6 hours here with them peaking right at this point. Same, you've got 4 hours. Let's see, 7 to 11. You got 4 hours right there of the LHCB. And so they are really, they're hitting it hard. I wish we still had the same model they took down that showed the collapse of our shields, guys. But we know it happens, and each time it does, different things happen. You saw 6,000 airlines or airliners get grounded because in one of the chips that navigates the plane, something hit. It changed from they're dealing with binary code. It changed from a 1 to a 0, and the one plane dropped 1,500 feet almost immediately. So they had to reset all of that. And those are effects of intensifying solar activity, and the strength that you're seeing here is tearing our shields down. Guys, and just a quick look at the cryogenics. I've talked about it before. It's part of their ion physics squeeze section. Cryo means cold. And each one of these, I've explained it before, but we got new folks. Each one of these numbers are sectioned within that 17-mile loop where they collide this. And they have to stay at basically the temperature of outer space, 2 degrees Kelvin. And like I said, if any one of these sections turns red, you'll start seeing the power being shut down. But right now, it looks very good. And I mentioned before, each one of these sections has a different color line. And when they're down, you'll see different color waves, and it's like spaghetti models for a hurricane. But right now, all of them are lined up very close. You can see just a few movements here and here, probably correlating to peak power time, things like that. But right now, they're full-blown running. Let's take a look at this illustration just a moment. You've got the sun here. This is a model. with the coronal mass ejection happening. It's pointed towards our planet. You're looking at the geomagnetic field of our Earth's shields, and these are the magnetic lines of force that go through the Earth, which is how the compass works. And when you have these particular openings here, guys, are called cusp, C-U-S-P. And when the energy from a CME gets past the outer shields, the magnetosphere and the magnetopoles, it can actually send radiation straight through these openings into the Earth's shields. Now, this changes, bounces around as these solar winds coming in, things like that. But it talks about geomagnetically induced currents and basically ground currents, saying that these GICs can result from geomagnetic storms, a type of space weather, an event in which Earth's magnetic field is rattled by incoming solar materials. Most GICs are triggered by coronal mass ejections, or CMEs, which interact with the magnetosphere. Notice that they're talking about the big power lines can carry this current. Not only that, let me scroll this down. Just something to always be aware of. They can run through any long metal structure, railroad tracks, power lines, underground pipelines. All can be affected by what the sun does to our planet. So CERN is underground. We're talking about underground pipes, right? And so there you've got two different currents that travel right over the area where they are at in the northern hemisphere. Now, let's take a look at this particular model. Guys, you've seen it in some of my videos, but you've got what's called field-aligned currents that are moving inside the Earth's magnetic shields, those lines. Your compass works on that. Now, you're looking here at the U.S., but around this side, you've got CERN buried 400 feet underground, I think. Anyway, so ground currents are induced, and they are created by energy coming into our shields. That energy can be transferred in a lot of different ways, but it can be transferred on the surface again, railroad tracks and all of that. But here we're talking about underground currents. In the yellow lines, those are directional. You see how they rotate? They're called Hall currents. But the Peterson currents are coming in here and going across. So you're laying like two coils very close together. And again, CERN is buried underground right over here, can take advantage of it very easily. And not only can they take advantage of the energy, but because they're tied into these two coils, because of the underground currents, they are collapsing the Earth's shields. When it hits and they're running full power, our protection can drop 60–70%. Now, this is an older model, but what they were doing was using the technology. They had satellites and other things to detect this ground current. You can see where everything's located here. The U.S. is this side, and Switzerland's over here. It says that the field-aligned current density is an ionospheric footprint, about 110 kilometers altitude. It says a day under moderate solar wind, predicted by open source MFACE. According to the solar wind conditions downloaded from the NASA OmniServe, it's an empirical mode extended from 10 years of CHAMP magnetic measurements. And that's what's happening, guys. You've got it, again, crossing in and going through the Earth, underground, tied into CERN's electromagnetic field. What have I said before? Which is 100,000 times stronger than the Earth's. Now, let's go back to 2019. Before they took that model down, this is what it normally looks like. Now, I showed you a portion of another video maybe a week or so ago. This is a different one, but this is kind of the normal events that happen. And the Earth is in the center. The white section indicates the sun-facing side, so all the solar energy is coming in here. This is our magnetopoles right there. And that's about how it would be on a normal day. Now let's move it forward. Solar activity is coming in, and then what did not ever happen until CERN started really getting powerful was what you're about to see. So check this out. and going back to 2019, and what I was doing, I would match it with the time CERN was running hot. You'll see it kind of expand. That's kind of normal. Incoming solar energy, it's like a big balloon. Then you're going to see CERN hit it as it's getting hit by the sun at the same time, and the shields start to collapse. You just saw something there. Now, what also is happening is that it's pushing down in the top. It's distorting the shields, and that's forcing the actual blow-off that would be behind the Earth at a different angle. Just look at the crippling things that are happening to our shields. The white circle, guys, here, the dotted line is a satellite band for the GOES system satellites, and they're the ones giving us this data. Look at that, almost touches it. And what's that doing is allowing solar radiation much closer to the Earth, closer than it was designed to be. Look at these on both sides. Poles are affected. It's, again, changing the angle. What that's doing is caused by the distortion in our shields. Look at this. This is a perfect example of why I guess they took the model down. But continuous distortion, as we go through this very slowly. Because why? CERN shields, and they say it in their documents, is 100,000 times more powerful than our shields. So when they run in their experiments, and like I said this back in the day, I don't know if it's an unintended side effect, but it's a critical side effect. You know, they may be trying to just run their power, do their tricks or whatever, but they may be actually trying to also control the magnetopause, our shields. But when you see that burn like that, see the collapse in the shields at the bottom towards the southern poles of our planet. Anyway, wanted to go through this. It's going to be interesting. I'm going to try to keep an eye on CERN as we go into the impacts of this. We'll just have to see how the timing works out. This model is invaluable, though. And guys, when you look at the auroras, which, by the way, since December 5th through today, you got small northern light boost as possible for the weekend. Now, this came out before the CME. So, again, we're definitely going to have them, but these auroras, these beautiful, but that's energy coming in, hitting our shields. And the redder it is, the more dangerous it is. It used to be just mostly greens that you saw. But as the atmosphere is more affected, the shields are critical. You start seeing that red. It's beautiful, but it's a sign of more radiation pouring in. A different radiation, more dangerous. But anyway, guys, just wanted to kind of update you. A lot of you are susceptible to these solar events and the geomagnetic storms. And plus, we always watch that type of event. We're watching it. You watch it, guys. It's a heads up. Be safe.